Good evening, students. Today we are going to discuss the grade 11 chemistry chemical equilibrium. So JEE and NEET questions. So 1 to 10 we can discuss today. So read the first question and try to understand this. If possible, you can solve it. Hope you have understood this on reading the question. So the equation here is 2SO2 gas plus O2 gives us 2SO3. And for this, the equilibrium constant Kc, when it is done in 1 liter vessel, they have found it as 2.5 into 10 to the power of minus 3. Now the question is, if you conduct the same reaction, very important thing, at same temperature, by increasing the volume of the vessel, that is into 2 liters, calculate the value of Kc. You know what is equilibrium constant. See, don't go with the normal method here, because the condition you have to check out, that is with the same temperature. Now let us write. So initially, if you consider volume V1, you take it as 1 liter, and in this condition Kc is equal to 2.5 into 10 to the power of minus 3. Now what is the question? If the volume is increased to 2 liters, find the value of Kc. Let us write it as K dash C. Now the important condition here is temperature remains constant, that is same temperature. So straight away you can solve this question, very simple. Always Kc depends on temperature. But here, because you have same temperature, Kc also remains constant. So therefore, if it is 2.5 into 10 to the power of minus 3, straight away you can write it as value is 2.5 into 10 to the power of minus 3. So K dash C also remains the same. So hope you have understood this, very simple. Don't go with the usual formula. Straight away, using the condition same temperature, if temperature remains constant, Kc also remains constant. Therefore, you can write the same answer. Now let us solve question number 2. Now question number 2, if equilibrium constant for the reaction 2AB gives A2 plus B2 is 36, find equilibrium constant for AB gives half A2 and half B2. See, we have discussed this in theory. So what is happening in the equation 2AB, now you have taken the coefficients are reduced to half. So we can write like this, the coefficients are reduced to half. Okay, that means if 2 is there, this is 1. So 1A2 is converted into half A2. So if the coefficients are, the number of moles are reduced to half, you have this equation, that is K dash is equal to root of K. Or you can write, if it is K2, you can also write it as K2 is nothing but root K1. So straight away a very simple question. So what is given here? So given K1 is equal to 36, therefore what will be K2? K2 is equal to root of K1, so root 36 nothing but 6. So you can write K dash or K2. Hope you have understood this, very simple. If you reduce the coefficients to half, then what you will do, you will take it as root of K. Suppose in other condition, if it is reversed, A2 plus B2 gives 2AB, then you know that it is nothing but K2 is equal to 1 by K1. So that type of questions also we can solve. Now what will be our answer here? 6. Let's move to question number 3. Now question number 3, you can read the question and try to understand this, then try to solve it in less than 1 minute. A very simple question. If equilibrium concentration for x2, y2 and xy are given respectively, they are asking for the initial concentration of x2 alone. So before the formation of product, what was the initial concentration? First and foremost thing, write the equation. So x2 plus y2, you have to balance that. So hence coefficient will be 2. This will be your equation. Now you know the standard method. What is the standard method? First one, we have to write it as initial concentration. So let us suppose you take initial concentration of x2 as small a and initial concentration of Y2 is small b. And product is not formed in the beginning of the reaction, so you take it as 0. Second one is at equilibrium the concentration of the reactants as well as product. So what will be the concentration? Because it is coefficient 2xy, we can take it as 2x. This will become a minus x and y2 will be written as b minus x. So this methodology already we have discussed. Very simple. If it is xy alone, you can take it as x, but coefficient is 2, hence you write it as 2x. So at equilibrium concentration of product will be 2x. An important thing here, what is that? They have given the concentrations. So what is the concentration of xy at equilibrium? So it is nothing but 8.9 into 10 square molar. So therefore we can write like this, given the concentration of the product 2xy, nothing but 2x, 8.9 into 10 square. So you want to find out x, therefore x is equal to 8.9 into 10 square divided by 2. So 2x will become divided by 2 now. So what will be the answer here? X is equal to 4.45 into 10 square. So we have got the answer here. And observe the options given. In the options we have -1. Here it is 10 power 3, 10 power 3 and 10 to the power of 3. So to make it easy, what you should do is convert a 10 square into 10 to the power of 3. So you know the method. I am again explaining you. 4.45 into 10 square into 10 by 10 you can make it. So 10 by 10 is 1, so you can write it 10 by 10 here. So what will happen here? So 10 square into 10 divided by 10. So nothing but 4.45 divided by 10 into 10 cube. So the value will be 0.445 into 10 cube. So x value, we got it. So you know the method, I have explained it again. So finally we got x value. What is x here? 0.445 into 10 to the power of 3. So with this value you can calculate x2, y2 as well as 2xy also. Now what is the question? Initial concentration of x2. So we can get a by substituting the value of x. So we can write like this. A minus x is equal to. So what is the concentration of x2 here? At equilibrium it is 1.2 into 10 to the power of 3. So let me write that. A minus x is nothing but 1.2 into 10 cube molar. Now you know the value of x. 0.445 into 10 cube is equal to 1.2 into 10 to the power of 3. Send this to other side. Minus will become plus. So 1.2 into 10 cube plus 0.445 into 10 cube. Hope you have understood this. Always write one below the other so that it is easy for the calculator. Now 10 power 3 remains as such. So here it is 4, 5, 6, 1. So we got the value of A, 1.645 into 10 to the power of 3 molar. So the nearest value 1.65. So what is your answer? 1.65 into 10 to the power of 3 molar. Hope you have understood this. Let's move to question number 4. Trying to solve question number 4. Active mass of 5.6 liter of oxygen at STP they are asking. See, we are familiar with active mass. What is the formula to calculate active mass? Number of moles by volume in liter. So this is your formula. So try to calculate this. First and foremost thing, how to calculate number of moles. 5.6 liters of oxygen is given at STP. Now, we all know that 22.4 liters of oxygen is nothing but 1 mole. So 1 mole of any gas occupies 22.4 liters of volume, that we are familiar. What is the volume given? 5.6 liters of oxygen. Find out the number of moles. So we need to find out the number of moles. So you can calculate it as 22.4x is equal to 5.6. Therefore x is equal to 5.6 by 22.4. So we know we can cancel easily 1 and 4. 1 by 4 will be 0.25 moles. So number of moles we got, and you know the volume in liters. On substitution, what you get? Number of moles is 0.25 moles and volume in liter is 5.6 liters. This will be your active mass. So option D is the right answer. Hope you have understood this. Copy the answer and let's move to question number 5. So question number 5, AB2 will dissociate in this manner. AB2 gas gives AB gas plus B gas. If initial pressure of AB2 is 600 mm of mercury, so initial pressure of AB2 is 600. Total equivalent pressure also at equilibrium, total equilibrium pressure is 800 they have given. And now they are asking find out Kp if volume is constant. So let us solve this. First one, you know the method. AB2 gas will dissociate into AB gas and B gas. We will write, if pressure is given, we can write like this. So initial pressure, so they have given the value, it is 600 and here it will be 0. Initially you don't have any pressure of the products because no products are formed. Second one, at equilibrium we can write like this. So here let X will be the partial pressure. Now this will be very simple, 600 minus X. What is given? They have mentioned that total pressure at equilibrium is 800 mm. So you know what is meant by total pressure. You have to add these three terms. Therefore 600 minus X plus X is equal to 800. So a minus X and plus X you can cancel. So 600 plus X is 800. Therefore X is equal to 800 minus 600. We can write it as X is 200 mm of mercury. So we got the value of X here. Now you can easily identify Kp value for this. The formula Kp, you know the formula, the equilibrium constant at partial pressure. If you consider, it is nothing but partial pressure of A, that is products AB and B, divided by the partial pressure of the reactants. Hence we can write like this, partial pressure of AB into partial pressure of B divided by the partial pressure of AB2. So products by reactants partial pressure. You know the value here. So what is that? If you want, you can write it as separately or directly you can calculate. So X we have, therefore PAB is equal to PB, nothing but 200 mm. And what is the reactants here? PAB2. 600 minus X, nothing but 600 minus 200, we get it as 400 mm. Substitute the value here. What do you get? Kp is equal to PAB 200, PB is also 200, and this will be 400. Hope you can easily get the answer. 200, 1 and 2, so this 2 ones and 100. Therefore Kp is equal to 100. Answer is B. Hope you have understood this. Copy the solution and let's move to question number 6. Next, question number 6. For the reaction H2 gas plus I2 gas gives 2HI at 721 Kelvin temperature, equilibrium constant Kc is given as 50. They are asking find out the Kp. See, if you know the relation between Kp and Kc, answer will be easy. What is the relation? Kp is equal to Kc into RT power delta Ng. So what is delta Ng here? Delta Ng is equal to the gaseous products, number of moles of gaseous products minus number of moles of gaseous reactant. So first of all, if you know what is delta Ng, then it will be very easy. So our universal gas constant and T is temperature. For this reaction, if you write like this, products. So products we have 2 Hi, hence we can write 2 moles, minus reactants you have 1 and 1, nothing but 2 minus 2. Therefore we get delta Ng is 0. On substituting this, what we get? Kp is equal to, Kc is given as 50, so 50 into RT to the power of 0, anything to the power 0 is 1, so 50 into 1, so therefore Kp is equal to 50. Sometimes the value will change here, then it will be divided by RT to the power of 1, so that and all we can see in the next questions. Hope you have understood this. Copy the solution and move to the question number 7. Next, try to solve question number 7. They have mentioned the reaction acid gas gives us 4s2. It is carried out by taking 2 moles of acid and 0.2 moles of S2 in a reaction vessel of volume 1 liter. Kc is given, and then they have given 3 conditions, that reaction quotient is 8 into 10 power minus 4 and reaction may proceed in backward direction or forward direction. And here options are there, either AB or BC or AC or all the 3 options. To solve this, first let us see what is reaction quotient. We know that reaction quotient Q is nothing but product concentration raised to the power of coefficient divided by reactant concentration to the power of coefficient. This already we know. So if you substitute this for this, we write it as reaction quotient Q is equal to S2 is the product. If you write the concentration, coefficient is 4, hence write it as 4 S2 to the power of 4 concentration divided by S8. So here coefficient is 1, so hence we will keep it as such. So we got the value of reaction quotient. Now, how do you find out the concentration? See, you know that the concentration is nothing but number of moles by volume. For this, first and foremost thing is 2. So if you write that, what will be the concentration of S2? Number of moles they have given, how much? 0.2, and volume is 1 liter, hence we will get the concentration of S2 is nothing but 0.2 mole. Similarly for S8, the concentration of this S8 will be taken like this, number of moles 2, volume is 1 liter, hence we get 2 moles. So very simple, you can substitute the same thing here. So what is the concentration of S2? Nothing but 0.2 to the power of 4, and S8 concentration is 2. So let us cancel this, 2 times and 0.1. Now 2 into 2, 4, 4 into 2, 8. So we get Q is equal to 8 into, now the decimals you take 0.1, 0.2, 0.2 and 0.2, hence 10 to the power of minus 4. So we got Q is 8 into 10 to the power of minus 4. So first one is correct. Now how to find out whether it is proceeds to backward or forward direction? So we have the relation. So what is that relation? Whether Q is greater or Kc is greater. So given Kc, what is the value of Kc? 6.3 into 10 to the power of minus 6. And how much you got for Q? 8 into 10 to the power of minus 4. Very easy. So 10 to the power of minus 4 is greater than 10 to the power of minus 6. Therefore, the reaction quotient is greater than the equilibrium constant. According to this condition, if reaction quotient is greater, then definitely the reaction proceeds in backward direction. In backward direction. We already know this. If Q is equal to Kc, it will be in equilibrium. If Q is less than Kc, it will be in the forward direction. But in this condition, because Q is greater than Kc, it will move in backward direction. So what will be your answer? Both A and B. Hence option 1 is correct. So copy the solution, very simple. Hope you have understood question number 7. Let's move to question number 8. Question number 8. For the reaction carbon solid plus CO2 gas gives us 2 CO gas. Partial pressure of CO2 is 2 and CO is 4 atmosphere. They are asking find the value of Kp. First and foremost thing, you know that there will not be partial pressure for a solid. We need to consider only the gases. So what is the equation? C plus CO2 gas gives us 2 CO gas. So in this condition we can write like this. So Kp is calculated as the partial pressure of CO. Coefficient is 2, hence we write it as P square divided by, so this we need not consider. So partial pressure of CO2. So this will be your formula. First and foremost thing, at equilibrium, they have given the value of partial pressure. What is that? CO2, it is given as 2 atmosphere, and for CO, it is given as 4 atmosphere. Substitute the value and find out what is Kp now. So CO, so they have given it as 4 and square, hence it is 4 square by P of CO2 is 2, nothing but 4 into 4 by 2, cancel this, hence we get answer is 8. So what is that? Kp is 8. Answer is D. Hope you have understood this, very simple. Ignore the partial pressure for a solid. So hope you have understood this. Copy the solution and let's move to question number 9. Next, question number 9. 2 moles N2 mixed with 6 mole H2 in a closed vessel of 1 liter capacity. 50% N2 is converted to ammonia. What will be the value of equilibrium constant? So you know this is Haber's process. First and foremost thing is, the condition is very simple. They have asked 50% of the reactant is being converted into the product. You need to understand that. First write the equation. N2 plus 3H2 gives 2 moles of ammonia. This is Haber's process. Now what is given, if you write like this, initial mole, so here they have given is 50%, that we will calculate 2 mole N2. So let us write 2 moles and here it is 6 mole, product is not formed. Next, at equilibrium, so we can write number of moles at equilibrium. So you know 2 times the coefficient, hence we write it as 2x. Here the coefficient is 3, hence we write it as 6 minus 3x. And here coefficient is 1, hence we write it as 2 minus x. Hope you have understood this. We have discussed many examples, hence we will get the number of moles at equilibrium. Next, so what is given? They have mentioned that 50% N2 is being converted into ammonia. So let us calculate here. Suppose 50%, nothing but 50 by 100 of how many moles? 2 moles is being converted into ammonia. So we can cancel this 2 times. So therefore we get 1 mole of ammonia. So very simple. So we can take it as x is equal to 1. On calculation we got the value of x is 1. So easily you can calculate the number of moles. So what is here now? So number of moles can be calculated 2 minus x for N2, nothing but 2 minus 1, therefore it is 1. This is 6 minus 3, so hence it will be equivalent to 3 moles. And for this 2 into 1, so 2 into 1 we have 2 moles. Hope we have understood this. See, when the volume is 1 liter, the concentration is nothing but equivalent to number of moles. So you know that the concentration is equal to N by V, hence it is 1 by 1 equivalent to 1. Here it is 3 by 1 equivalent to 3, and here it is 2 by 1, nothing but 2. See, whenever the volume is 1 liter, the concentration is equivalent to number of moles. So we got the concentration. Now apply the formula. What is the formula? Kc is equal to the concentration of products raised to the coefficient by concentration of reactants to the coefficients. So NH3 concentration square by, here N2 coefficient is 1, therefore no power here, so simply we can write it as 1. So H2 concentration to the power of 3, because coefficient is 3. Hope you have understood this. Substitute the values here. Concentration of NH3 is 2, so 2 square, 2 into 2 by, here what we have for N2, it is 1 into H2 is 3, so 3 into 3 into 3, because it is cube. So what will be your answer? 4 by 27. Therefore Kc is equal to 4 by 27. Hope you have understood this. Answer is A. Copy the solution and let's move to the last question. Question number 10. Now the last question. Question number 10. NH2CO NH4 solid gives to 2NH3 gas plus CO2 gas. So here equilibrium pressure, that is total pressure, is 3 atmosphere, and they are asking to calculate the equilibrium constant in terms of partial pressure. So what is the equation here? So we have NH2COO NH4, and by observing solid you can ignore this. So no partial pressure for this, gives us 2NH3 gas plus CO2 gas. So if you observe, the formula for Kp will be equivalent to, so partial pressure of the products, right, into PCO2. See why you wrote a P square? Because the coefficient is 2. So this is your formula. There is no denominator because this is solid. Now to identify the partial pressure, what is the formula? So we have the formula to calculate partial pressure as mole fraction into total pressure. So very important formula. How can you calculate the partial pressure? By taking mole fraction into total pressure. Now let us calculate first for the partial pressure of NH3. What will be the mole fraction? See here, you know that it is number of moles 2 and 1. So total number of moles, so we can write like this, number of moles of NH3 by total number of moles into, what is the total pressure they mentioned? 3 atmosphere. So into 3. So what is N here? N is equal to 2 divided by total number is 2 plus 1 3. So 2 by 3 into 3. So we cancel 3, therefore, so we have the value for partial pressure of NH3 is 2 atmosphere. Hope we have understood the calculation. Now second one is, what is the partial pressure of CO2? Again, mole fraction of CO2 by total number of moles into 3. Number of moles of CO2 is 1, total is 3. So on cancellation we get the partial pressure of CO2 is 1 atmosphere. Observe the calculation. Hope you have understood this. Very important formula. Partial pressure is mole fraction into total pressure. On substituting, what we get? Kp is equal to P square NH3 into P of CO2. So what is the partial pressure? 2. Hence we have 2 square, hence 2 into 2, and partial pressure is 1. So what will be your Kp? 2 into 2, nothing but 4. Hope you have understood the solution. So in this session we have completed question number 1 to question number 10. So hope you have understood this. Copy the solution and practice all this. So similar type of questions you may have in JEE or NEET. Thank you so much.